Well, we've reached my favorite point of ISIS, and that is the basic implementation and verification. It's my favorite part of just about any Cisco topic because we get into the live interface and see some action, see some ISIS configurations. But before we do that, we're going to start off with how ISIS forms a routing table. One more conceptual slide on how ISIS puts all the pieces together, how it takes the OSI underlying infrastructure and then runs an IP network on top of it. From there on out, we're in live interface. I've got 4 routers here set up in 3 different areas. Well, the diagram says they are, but they're actually not set up yet. We're going to set them up in 3 different areas: level 1 routing, level 1/2 routing, and level 2 only routing. We'll get it all set up. Then, as always, I'll splice in the verification commands as we go through. I prefer to do those as we do it rather than waiting till the very end and saying, oh, here's all the verification commands, because that's how you do it in the real world. But before we get into those verification commands and the rest of the configuration, I did promise you this one conceptual slide. Forming the routing table with ISIS. First off, remember with me, ISIS is a link state routing protocol. And that means that every single router in the same area has to have exactly the same link state database. There's no path left unturned in the area. They know about everything. So if there's a failure of a link, all they need to do is look back at their database, run the SPF algorithm, and find the backup path. So once all the routers have exchanged their routes, and we talked about this in the concepts part 2 video, the one right before this. We talked about how they exchange their routes using those link state packets. And once that happens, the routers will find the best way to reach each other based on the lowest cost. Now that is done using the SPF algorithm, just like OSPF. Now in step 1 right here, this is solely the OSI protocol. All the routers are finding the best way to reach each other's OSI address, the one address we're going to be assigning them, that dictates what system they are, what area they're in, and the end cell, the last 2 bits of 00, or last byte of 00. They're just finding how to reach each other. Doesn't have a thing to do with IP. Now, level 1 and level 2 routers will perform completely separate route calculations. What that means to you is if you have a level 1/level 2 router, the SPF algorithm runs twice. 1 to find all the level 1 paths within the area, and 2 to find all the paths across the backbone, all of the other areas. What are the best path to reach the routers in other areas? So it is a little harder, and that gives you a good recommendation. Your level 1/level 2 routers should probably be a bit beefier, if you will, than your level 1 routers, because they're going to have to run that algorithm twice, and they're going to have a much larger routing table. From there, all the best paths are added to the OSI routing table. Catch that. The OSI routing table, everything we've done, step 1 through 3, is all OSI based, and you will have an OSI routing table showing how to reach all the different OSI devices in your domain. In your autonomous system, I should say. Domain. That's a Microsoft word. Let's get that out of here. Step 4, a second algorithm is run, and this is where it gets interesting. It's known as partial route calculation for the IP routing table. Here's the scoop. When they created integrated ISIS, or I should say this, when they created ISIS, they built it with 2 algorithms. The original ISIS had SPF to find the routes between the routers, and then it had PRC, partial route calculations, to find the routes to the end systems. Remember, we had the ISES protocol, which allowed the end systems to communicate with the routers as kind of like a DHCP. They find their default gateway out with that protocol, and the router would learn to communicate with them by running this PRC algorithm. Now here's the bonus. PRC is much easier on your processor than SPF. It's a much lighter algorithm. It's lightweight to run. So let's put this all together. When they created integrated ISIS, they said, there's no reason to run SPF to find the best IP routing table. There's no reason to run SPF twice. Why not run SPF to find the best path between the routers? That's the OSI routing table. Then we'll run PRC for the IP routing table, thus making it much easier on your router processor to calculate the paths through the IP network. Here's what that means to you. A network goes down, SPF doesn't have to run. It just runs PRC and says, oh, IP routing table changed. Much easier on the processor. A network comes up, networks are added, new paths are formed. All of those just run the PRC algorithm, which is so much better on your router's processor in the long run than OSPF. That's why when we talked about the benefits of ISIS over OSPF, one of the benefits is that it is easier on your router's processor. The only time the SPF algorithm has to run again is if a full router either goes down or comes up, because that affects the OSI routing table. That's when SPF has to run again because there's now a gaping hole in the network. Hopefully you don't have too many router failures, but IP networks coming up and down, it can handle those all day. Once the PRC algorithm runs, the best path from that algorithm ends up in the IP routing table, and thus we have a fully generated table. We're at the ISIS configuration. Sorry for the sadistic laugh. I have a cup of coffee here, so I'm a little buzzed. Configuration is the high point of any Cisco video, but right here, here's our network diagram. And before I pull up the configuration window, I want to go over it with you. 3 different areas, 1, 2, and 20. Area 1 and 2, I've got kind of as representative of maybe just our branch offices or our non-core network. Area 20 is meant to represent the backbone of the network. If you think back to the ISIS concepts videos, that's one of the designs I showed you, was where you had a dedicated area just as the backbone. Now, keep in mind, this isn't the backbone area. It's not like OSPF. It's just this is the area where all of your core routers exist that just provide the connectivity for every office in your organization or every area of your organization. Area 1 and 2, those are essentially like branch offices or maybe corporate office networks where one of them might be in Arizona, one of them might be in Michigan. Of course, there's only 2 routers in one and one in the other, but imagine that as being like 20 different routers in each one of those areas. Now, router 1 is going to be configured as a level 1 only router. Router 2 is going to be a level 1/level 2. We've got the backbone. Router 3 will be a backbone only router. That will give us experience seeing each type of router configuration, every single one of them. And then over here in area 2, we've just got a level 1/level 2 router that we're going to configure in that area. Now, in Area 1, I have 192.168xx networks, most of those hosted by Router 1. Area 2 has some 10 networks, most of those hosted by Router 4. So we'll be injecting those into the routing table. Show you a little basic summarization as well, because we don't want those reaching the backbone unsummarized. Next to each router, you can see its net or NSAP address that I've assigned to it. You can see Area 1, I'm using the private addressing 49.0001. And then the system ID after that. Same thing here, 490001, and then the system ID after that. I followed my recommendation that I gave you where I just make the system ID match the router number. But do remember, those have to be unique in the real world. So a lot of people will use MAC addresses instead of just a straight number scheme like I've got on the screen. So with that in place, let's get going. I'll bring up my configuration window here. Oh, and I forgot. I upgraded to Vista last week, and look at these thick borders. You see these things? I used to have a nice slim Windows XP style window with no borders, and now I've got these big, thick borders on here. Can't figure out how to turn them off. Stupid Vista. All right, here we are. We're sitting on router 1 right now, and let's just hit the high points. Router 1 is a level 1 router. There's its NSAP address. So to get into the configuration on this, we go into global config mode, and I should do this first, show IP protocol, just to make sure, yep, no routing protocols are running. And just like any routing protocol, I'll type in router ISIS to turn it on. Now, if you hit the question mark, you'll see here that it follows up with word which is an ISO routing area tag. Now, if you think back to OSPF, OSPF requires you to type in a number here. So you would type in router OSPF and 1 or 2. I think it goes up to like 4 billion that you can type in there. ISIS is a little more flexible than that. It'll let you type in a number or a name. I could type in router ISIS Jeremy if I wanted to, and that would identify this routing process just like it does with OSPF. Now, here's the tip. I would recommend not doing that, not typing in anything, because you can see right after this is just carriage return. If you do that, just like that, it will take you into the ISIS routing process and use a default tag of 0. Now, the good news about that is you never have to remember that tag. When you enable ISIS under the interfaces, which we'll do in a second, you can just type in router ISIS instead of having to remember this tag everywhere. So if you choose to use a tag, you're going to have to remember to use that tag everywhere in your config, whereas if you just leave it blank, you won't have to remember it. Now, underneath the routing process, I'm on router 1 here. My first major task of an ISIS is to give it that NSAP address, which is this one right here. 490001 identifies the area. There's its system ID and an NCell of 00. Now, you might remember I said NSAP address is also called the net address, which is an NSAP address assigned to a router. So we type in the command net followed by what we want our NSAP address to be. Now on this one, it's 49.0001.1111.1111.1111.00. Now remember, read those right to left. System ID is all ones, area is 49.001. Notice it says this is some long number that is up to 20 bytes, so they don't show you the full syntax there. As soon as I do that, I've now assigned this router an identifier. Done under the routing process. Can you believe that? That's all I have to do from there. So now all I need to do is turn on ISIS under the interface. Now you might be thinking, well, Jeremy, don't you do that with the network command just like we did in the other routing protocols? Not ISIS. They do it much more logically, in my opinion. We enable ISIS under the interfaces we want to turn it on for. So instead of typing in network and trying to figure out some funky wildcard mask and assign it to certain interfaces and make it run, and what's that network command do anyway, we just go under the interface and we say, I want this interface to run ISIS. I want that interface to run ISIS. So here's the scoop. All I need to do is go underneath the loopback interfaces. I'll start with those. By the way, the loopback interfaces are going to be what simulate our networks. Sorry, my brain just checked out there for a moment. Down here, you can see 192.168x networks. Those are all going to be simulated, those roles played by the loopbacks. So I'll get under loopback 0, and this is how you turn it on under an interface. Just type in IP router ISIS. I'll hit the question mark, and it shows right there. If I had a tag, I would have to type in that tag here, but thankfully I don't, so I'll just hit enter. Exit out of that. Interface loopback 1. IP router ISIS, done. Loopback 2, router ISIS, done. Loopback 3, router ISIS, done. You get the point. I turn on ISIS under the individual interfaces. I'll do a show IP protocol at this point, and you can see the routing protocol is ISIS. It's routing for networks, loopback 1, 2, 3, 4, or 0, 1, 2, 3. So it's identified what interfaces will be running ISIS. We've now included those in the ISIS routing process. Now before we turn on ISIS on our serial link here, there's one thing I should mention. The default router type for ISIS is level 1/level 2. So it will be an inter and intra area router by default, which in this case, I don't really want. I want to make sure router 1 is a level 1 only router. So here's how you do that. And I want to do that before I configure the serial interface because I don't want it forming unnecessary neighbor relationships. I'm going to go under the routing process, router ISIS, and all I do is type in IS type followed by what kind of router I want this to be. Level 1, level 1/2, or I don't know why they made the syntax is level 2 only. I don't know why they just couldn't put level 2 just like they had level 1. I don't know. Either way, I'm going to type in level 1 because that's what router 1 should be. Immediately, all its interfaces are considered level 1 interfaces, and it will only form level 1 relationships on those interfaces. Now, I'm going to turn it on for the serial interface. The serial interface that this one is using to connect to the other router is serial 0/2 or 0.2, I should say. So I'll type in interface 0.2 IP router ISIS. Enter. At that point, we are now running ISIS on all the necessary networks and interfaces that we should be. Type in show IP protocol. Sure enough, you see right here, serial 0.2 is one of our included interfaces. Now let's hop up here to router 2 and we'll configure a level 1/level 2 router. Hop up, router 2. Here we go. A little faster this time, router ISIS. I assign the net 49.0001 because it is in area 1, and then a system ID of all 2s. Good. Now this is a level 1/level 2 router that we're configuring. So when I type in the IS type, I don't need to change this. This is the default, level 1-2. So I can exit out now and go to my interfaces. Let me just, no do command here. I'll do a show IP interface brief. I need to go under interface serial 1.1 and type in IP router ISIS. That is now included in the ISIS routing process. Now here's a tip. This router 2 is a level 1/level 2 router. So any interface that you turn on ISIS for is going to automatically try and form both level 1 and level 2 relationships. Now good thing, because we configured this as a level 1 router, so it's only going to form level 1. But why should I send out level 2 hellos on that interface if I know that only a level 1 router will exist there? So all I need to do here is just go under this interface and type in ISIS circuit type followed by level 1. Which configures this router to only form a level 1 adjacencies on this interface. So we've just cut off some of the hello traffic between router 2 and router 1 because it's now just sending level 1 hellos. Remember, level 1 and level 2 is almost seen like two completely separate routers within one. So it forms two totally separate relationships. At this point, we should be able to begin our verification. So I'm going to jump back over to router 2 and just do a show CLNS neighbors. Now, a little review before I hit that return key. CLNS is the equivalent in OSI to the IP protocol of TCP/IP. It's the connectionless network service. It's just like IP. It's unreliable. It relies on upper layer protocols for reliability. It's what allows communication in OSI. It's how the global addressing works. So I'm going to type in show CLNS neighbors, and we can see on router 2, it is seeing router 1 out serial 1.1 as its interface. Now you see this SNPA. That stands for Subnetwork Point of Attachment. This will list whatever layer 2 mechanism you're using to get there. Now I happen to have router 1 and router 2, even though it's not shown in the picture, connected by frame relay. So it's saying, hey, I'm using a layer 2 address of DELC 201 to reach router 1. If we were connected on an Ethernet segment, you would see a subnetwork point of attachment of a MAC address. If you were connected on HDLC, HDLC has its own little proprietary layer 2 addresses, so it just puts ** HDLC underneath here. But whatever layer 2 mechanism you have will be shown right here. It shows a state of up, hold down timer, how long till it's dead, what type of relationship it is, and then of course the protocol that it's running on top of that. Now I can type in show CLNS neighbors. Let me see if I can type it out right. Detail. And that will also show me the area address that this neighbor is in, the IP address. Notice it has a little star just saying, by the way, I'm not supposed to know that. That's an integrated ISIS feature because all this is supposed to be OSI related. And then it shows the uptime of that neighbor. In this case, 7 minutes, 13 seconds. So now I can type in, let's do some more verification, show CLNS interface. I guess that makes me glad TCP/IP run. 1. IP is a lot easier to say than CLNS. So I'm going to type in show CLNS interface, and I'll focus in on serial 1.1, which is the interface connected to that neighbor. And I can see everything about the interface, what encapsulation it's using. I can see what sort of neighboring system it's formed a relationship with, how the circuit type is configured, what routing protocol is running. Remember, CLNS has nothing to do with ISIS, other than it being the layer 3 addressing protocol that OSI use. So it's saying on top of that, you are using ISIS as your routing protocol. Here's where the next hello is due. Here's how many adjacencies you formed, and so on. So at this point, I'm assured that router 2 is working and that we have a level 1 relationship over with router 1. I'll type in show CLNS neighbors just on router 1 to give us its perspective. And you can see it has formed a level 1 relationship with router 2 over there. Delcy number, everything is shown. So I'm feeling pretty confident. Oh, and we should, I guess, by the way, check the IP routing table, right? I'm back over on router 2, who should now know about all the loopback interfaces that router 1 has told it. And I'll type in show IP route, and it does. You see that right there? A little I represents ISIS. And then you can see that those are level 1 routes that are coming out and being learned from router 1. So good news. We have ISIS configured between those two routers. Let's move on to router 2 and router 3 and form that level 2 relationship. While we're sitting on router 2, I might as well finish that up and get the relationship going from its perspective. So I'll do a quick show IP interface brief, and it is using serial 1.3 to connect to router 3. IP router ISIS. Now, again, it's going to start sending out both level 1 and level 2 hellos because this is a level 1/level 2 router. So I'll do that ISIS circuit type, and this one is a level 2 only router. Have to have that only keyword on there. Now I've isolated it down just to send hellos at level 2. Let's move up to router 3. Router 3, let me do a quick show IP protocol. Just want to make sure I've got all the OSPF. Oh, I'm glad I did. No router OSPF1. Yank OSPF off of there. All right, I'll do router ISIS, no tag, and then I will type in net 49.0020 because it is area 20. .3333. Good. So we have the net configured there. I'll type in show IP interface brief again. We are using serial 0/0.2 to connect back to router 2 and .4 to go back to router 4 down here. Let's get those both set up. Now, on both of these, I'm only going to be forming a level 2 relationship. Oh, and you know what? You know what I forgot to do? I forgot to configure this as a level 2 only router. We're underneath the routing process right now, so I'll type in IS type level 2 only. Remember, underneath the interface, the circuit type says what hellos you have, but this is where you configure what kind of router type it is. It's under the routing process appropriately placed. So I'm going to get under interface serial 0/0.2 and type in IP router, or wait a second. Yes, IP router ISIS. Turn on ISIS under that interface. And, you know, while I'm underneath here, I might as well do it. I'm going to type in ISIS circuit type level 2 only. And I'm going to type that in because, first off, this is a level 2 only router. It's only going to send level 2 hellos, but this is just kind of a for my comfort sort of thing. It's, you know, you might as well do that. Just isolate it down under the interface as well. Just in case we ever change this into a level 1/level 2 router, I know that it will only form level 2 relationships still on that interface. So we're going to, under serial 0/0.4, type in the same commands, level 2 only. And at this point, we should be able to type in show CLNS neighbors, and let's see what's going on. Beauty. We've got router 2 has formed a neighbor relationship with router 3, so we're humming along right here on this link. Let's hit the details on there. And we can see that its IP address is showing up right there. The area that it is in is 49.0.0.0.1, even though we are in 49.0.0.20. So it's formed a relationship across the link there. I'm going to type in, let's just do a show CLNS blanket statement, because that will verify our net command and show our area correctly configured on here. So I'm seeing the level 2 relationship configured. I'm going to do a show IP route now, and let's see. Look at this. It is transferred the area 1 routes over to, or I should say the area 1 routes into the level 2 database. It does that by default so that the other areas will know about it. It's just like OSPF with the ABRs. The ABRs will allow the routes from the areas to pass through them. They will, it's not like it cuts the routes off. And same thing here, it doesn't cut the routes off from level 1 database. It will move them into a level 2 database role. So I'm seeing now the level 2 database for all the loopbacks that we have configured down there on router 1. I'm also seeing the WAN link showing up between router 1 and router 2. Now, before we move on, before I configure the relationship between router 3 and router 4, let me show you how to summarize in the ISIS world. This is done from the router configuration mode, and I'm going to go back to router 2, because if you look, we've got some inefficient routing here. I know that all of the 192.168 networks are in area 1, so why not sum that down to a single route? Jump back here to router 2. I'm under the router ISIS process. Now underneath here, I'm going to use the command summary address. There's no multiple commands like there is in OSPF, one for the ASBR and one for the ABR. Just one command here, summary address, what we want the summary address to be. I'm going to do some lazy summarization, so forgive me. I'll do 192.168.0.0 with a subnet mask or summary address 255.255.0.0, not a wildcard mask. Now it's going to ask me the question, where do you want this summary to go? By default, it's only going to go in the level 2 database because Cisco realizes that's where your summary routes happen. You're going to be summarizing your level 1 database into the backbone, into the level 2 database. But for good measure, we'll type it right here. We'll say level 2 will be where the summary address goes, just to show you there's no other syntax after that. We are now injecting a summary address into the level 2 database. Let's hop back over to router 3, which is the parent router in the backbone, and do the show IP route here. Beauty. Look at that, guys. We've taken all of those routes from area 1 and squished them down to a single route in the backbone database, in the level 2 database of 192.168.0.0. Now, of course, if we go back to router 2 and do a show IP route over there, we're going to see all the more specific routes because they're still in the level 1 database. It's not like they've disappeared. It's just we now have a summary route. You see the little SU? That's SU. That's the summary route for the 192.168.0.0 network. It's pointing to null 0 to keep those routing loops from happening again. Remember, that will only be used, this summary route is used when somebody's accessing something that is not listed as a more specific route in the routing table. We talked about that when we got into, I believe it was OSPF or AIGRP, is why it points to null 0. So we are successfully doing summarization. Let's set up this last relationship here. I'm going to go to router 3. I'll go quickly on this. Let me do a show IP protocol. I set this up for both interfaces, right? Right. Okay, so we're good on router 3. I'm going to hop over to router 4, which should have no protocols running, and it doesn't. So I'm going to type in router ISIS. We're in the last area, 49.0.0.2. System ID in there. I will type in the IS type because this will be a, well, it's level 1/level 2 by default. So we'll do a level 1/2 that I've hard coded in there. And now I'll do a show IP interface brief. We are using this one right here, serial 0/0.3. So I'll start with that interface. Interface serial 0/0.3, and I'll do IP router ISIS. ISIS circuit type is going to be a level 2 only, because this is the relationship between router 4 and the backbone. Now, of course, this is a level 1/level 2 router, and there's no other routers in this area. That's a little odd, but this is a lab environment, so we'll stick with that. Let's get underneath the interface loopback 0, IP router ISIS, 1, 2, 3. So we have ISIS configured on all of those interfaces at this point. So I should be able to type in show IP protocol, verify that we're running for all those, show CLNS neighbors, and you can see router 3 has formed a level 2 relationship. Let's go check router 3's routing table. And we are seeing level 2 routes now coming from area 2. They are not summarized, so they're not pretty. Let's fix that. I'll do a show IP route on router 4, and you can see that we have the summary route that's coming in, and then all our WAN links that have been advertised into ISIS. So I'm going to get under router ISIS, summary address. Very lazy summarization. Forgive me. I almost feel bad doing a summary address that looks like that. I'm just going to keep the default, which is a level 2 only advertisement. And at this point, I should be able to hop back up to router 3, show IP route. Bam! I feel like Emerald on the cooking show. Look at that. We now have summarized address for both area 2 and area 1. So, my friends, I will leave it to you. Which one do you think is easier? ISIS or OSPF? I'm not going to answer that question, but I'm not going to answer that question. I'm just going to leave it at that. So let's wrap things up. You have seen at this point a complete configuration of ISIS. We first off started with the question of how ISIS forms the routing table. How does ISIS really chart things out and transfer the OSI routing table into the IP routing table? We saw it in theory, and then we saw it in action as we configured ISIS. We set up level 1, level 2 only, level 1/2. We set up all the router types you can. We did summarization. We did verification, checking out the neighbors, checking out the routing table. Oh, wait a sec. I'm going to jump back here. There's one verification command. Of course, it hits me now that I did want to show you. It is show ISIS topology. This, by the way, is, oh no, this is the topology database that shows everything that ISIS knows about. It's all of the different routers in the link state database. So this is a great way to verify that it's receiving everything. Now that I do this, of course, I suddenly remember I forgot to talk about the metric. Last thing we'll talk about. I'm talking about it on the summary slide. That's okay, right? We have ISIS right here. So last thing I'll talk about is the metric. Remember, the metric is 10 on every interface by default, which makes ISIS route just like RIP. It's like hop count because it doesn't factor in the bandwidth. So we need to set the metric on some of our interfaces, and let me show you how to do that. It's a piece of cake. Don't worry, I'm not introducing a huge concept here. It's just like the bandwidth statement is for OSPF. You type in bandwidth and what you want the bandwidth to be. But in ISIS, you type in ISIS metric and then what you want the metric to be. You can see the default metric is a number from 1 to 63, and this is where you're going to need a spreadsheet where you map out what bandwidth values, somewhat equivalent to these values, are right here. So, and I mentioned this in the concepts, you might have like a T1 equals a 40 on the default metric, a fast Ethernet link equals a 10, you know, some sort of scale that you would have to create, because by default everything is 10. So just type in the metric that you want. You can choose what database to put it in, level 1 or level 2. Now on newer versions of the iOS, they have started getting into the true OSI specification of allowing delay, and then the next one would be expense. It's just like EIGRP where it's a compound metric. However, 90% of the world will only use the default metric, which is just that first number that you type in there. So I'm just going to type in metric 20, and that will apply to the level 2 database because router 3 is our backbone router. So at that point, I've assigned a higher cost to my neighbor relationship between router 3 and router 2, and that will be reflected in the routing table. When I do a show IP route, all of the routes that are coming from router 2 are going to have a higher cost than the others do. You can see that right here. This is the summarized route. You can see we have a cost of 40, whew, which is blowing away what we're getting from this area right here, typically just a 20. So that gives you an idea of the metric. Okay, conscience is clear. I can come back. We talked about configuring ISIS now in all its glory. That was the last command. Setting the metrics, setting the summary address, setting the relationship types, setting the router types, all of that. We then looked at the spliced in verification commands, which are not like our IP verification commands, where we just type in show IP ... We have show CLNS, which is the IP-like protocol for OSI. I hope this has been informative for you, and I'd like to thank you for viewing.